What do you think?
It's fine.
You know, I
You really
just,
can see.
You can,
Can you see?
I can see without the sun.
Good morning, Garrett. Alrighty, so we are going to start with chapter 3, just the very beginning of chapter 3. So page 129 is where we're going to start today. So we can kind of walk through the chapter, talk about what we've learned in this chapter to prep for the test. So let's see, let me bring up my screen. Where's this going? Very beginning. So okay, so chapter 3, if we look on page 128, it has kind of a, what's this chapter about? This chapter is about lines and angles, properties of parallel and perpendicular lines, 6 ways to prove that lines are parallel, and how to write an equation of a line with given characteristics. So mainly focusing on perpendicular and parallel lines in this chapter, okay? So when we talk about parallel lines, what is our definition of parallel lines?
Lines that have the same slope.
Okay, they have the same slope. Where are they located? In the same plane. Good. So we know that they are going to have the same slope. They are located in the same plane. They are coplanar. And because they have the same slope, that means that they're not going to do what? They're not going to intersect, okay? They cannot ever intersect or cross over each other because their slopes are exactly the same. That would help. Good. What? Yeah. Okay. All right, so we said that they do not intersect. They're located in the same plane. They have the same slopes, okay? And so we talked about how you can not only have parallel lines, and notice that our parallel lines are indicated with our little arrows. Those little arrows tell us that they're parallel on the arrows, but you can also have parallel planes, okay? So not only lines, but planes as well. We talked about how you can show that things are parallel using our parallel symbol, okay? So basically that's the 2 lines that show. So one of the things for you to be careful about is, especially on a test, if you're writing symbols, to make sure you're writing the symbols correctly, okay? So we talked about looking at parallel lines in an object. We talked about how we can identify them in an object. We had the parallel postulate. If there is a line and a point not on the line, then there's exactly 1 line through the point parallel to the given line. Yes?
Does you have like a symbol? Like parallel lines have like 2 lines.
Yeah, so like you would describe them, you would have whatever line is parallel to whatever line. So the symbol is those 2 lines.
Okay, but like does you have like a symbol? Skew lines have a symbol.
Do skew lines have a symbol? No.
Okay.
No, I'm sorry. I missed hearing you say skew. And then the perpendicular postulate says that if there is 1 line and a point not on the line, then there's exactly 1 line through the point perpendicular to the given line, okay? So basically I can only have, if I've got a point, if I had a line and a point, then I can either have 1 line going parallel and 1 line going perpendicular, okay? So thinking about perpendicular lines, what did we learn about perpendicular lines? when perpendicular intersect, what do they form? When a perpendicular line intersects another line? 90-degree angles, okay? So we know that we're gonna have a 90-degree angle, whether they're slanted or straight up and down or side to side, we've got a 90-degree angle form. And so if one of my angles is 90 degrees, that means all four of them. It makes 4 90-degree angles, okay? So a perpendicular line is gonna intersect at a 90-degree angle, but in goal 2, on the next page, was that page 130? We learn about, or actually 131, we learn about transversals. And transversals are going to be lines that cut across another line, but not at a 90-degree angle, okay? And so when a transversal is formed, we have all these different angle relationships here that are developed, okay? So we learned about corresponding angles. Corresponding angles have to do with lines that are on the same side as the transversal, but in the position where it's above the other two lines, okay? So our corresponding, they're going to be on the same side as the transversal, but in the same given location, okay? Then we went over, the next one is alternate exterior angles. Remember when we talked about the word alternate tells me that one's going to be on one side of my line, the other will be on the other side of my line. So that's what alternate tells me. Exterior tells me that they are outside of the lines being crossed across. Okay, so alternate, one's going to be on one side, the other's going to be on the other side, and they're going to be outside of the lines that are being crossed. So alternate exterior. Knowing alternate exterior helps us with alternate interior, because these are going to be the same. They're going to be on either side of my transversal, but they're going to be inside the lines that have been crossed over, okay? And then we had consecutive interior angles. And remember, consecutive interior angles are located on the same side of my transversal, and they are both located inside my lines that are being crossed over. And what did we learn that consecutive interior angles add up to equal? 180 degrees, good. All right, and it says consecutive interior angles are sometimes called same side interior angles. So that's a way to remember it, that when you see these that are on the same side interior, we know that those are consecutive interior angles, okay? So we worked with learning those different relationships, those locations, being able to understand their placement. Moving on to page, what pages? It's cut off. So it's starting section 1, 2. Did I just jump right over? Okay, so page 136, proof and perpendicular lines. In this section, we learned about the flow proof, okay, and that's at the bottom of page 136 and over on 137. We talked about how basically you can start out with your given and you kind of have a flow chart, if you will, where you kind of go from one concept, draw an arrow to the next concept, or if it's something that's the same, you would go from the side to side. Like I said, I'm not going to stress too much about the whole proof situation. We will have some proofs where you will have some given statements and some given reasons, and you have to fill in blanks. Yes.
Are there going to be column proofs on this?
So there will be the two column proofs. Yes, but like I said, you'll have some statements, some reasons, and then you'll have the blanks to fill in. Okay. The reason for that is I'm wanting you to continue learning the relationship from step to step. I'm not too concerned, and I also want you to understand why we've gone from step to step. But so think about, and I can't remember if I said this yesterday in class or if I was talking to somebody else about it. But so stop me if I've already told y'all this. So think about when we're solving for X, and remember at the beginning of the year where we would solve for X and we had to say, was this a subtraction property of equality? Was this the multiplication property of equality? Was this the distributive property? And we had to tell what we did each step of the way to solve for X, and then we had to tell what the property was that went along with that, okay? So in doing that, we were having to justify why we did what we did. But think about, when did you start solving for X? What math level were you in when you first started solving for X? Pre-algebra? Probably you might have even seen it before pre-algebra. You could have seen it in other elementary level math, the whole concept of X. So think about, maybe you saw it in an elementary level math. You definitely saw it in pre-algebra. So you had a year of pre-algebra, you had a year of algebra that you were working on those concepts. So now when we're doing it, you are solid with it, okay? You've had 2 years of doing the same type of thing. Understand that now we're jumping in and we're doing something like that, but we've got a whole new vocabulary. We have a whole new system of symbols. So understand it is going to be a challenge. Sometimes it's a challenge solving for X, and we've been doing that for a couple of years. We're jumping in and we've been doing this for 8 weeks, if not even that long, doing proofs, okay? So don't be so hard on yourself, that it is a challenge, okay? It is hard. We've got all new vocabulary, we've got all new reasons, we've got all new symbols that we're having to deal with, okay? But like I said, my concern is not, can you go, you know, from top to bottom and list every statement and reason. My biggest concern is, can you see the relationship from what happened here to here, and what was the reason that they went from step to step, okay? Alrighty, so we did learn that there are such things as flow proofs, and we also talked about how I'm not going to stress about those. So on the next page, 137, we have 3 new theorems, and we talked about how these are not named. They are just named Theorem 3, 1, 2, and 3. But so kind of understanding them to be able to describe them. Theorem 3.1, if 2 lines intersect to form a linear pair means what? They equal 180, form a line. If 2 lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Theorem 3.2, if 2 sides of 2 adjacent acute angles, okay, acute means what?
Bigger than 90.
No, acute. Oh, it's so cute. Smaller than 90. And adjacent means?
Across from?
Right next to. Adjacent means next door, okay? Or beside. If 2 sides of 2 adjacent acute angles, so I've got side-by-side angles that are each less than 90 degrees, and if they are perpendicular, if 2 sides of 2 adjacent acute angles are perpendicular, then the angles are complementary. Complementary means what? 90 degrees, add together to make 90 degrees. So do you see in that one theorem, we've had adjacent, acute, and complementary. These are 3 new vocab words that we're having to put together in one. Theorem 3.3, if 2 lines are perpendicular, then they intersect to form 4 right angles. And we already talked about as we were describing that. Example 2, proof of theorem 3.1, we're just going to kind of scoot right over, and then we had our practice for 3.2. So now we're going to move on to section 3.3, parallel lines and transversals on page 143. All right, page 143 started out with postulate 15, corresponding angles postulate. And this states that if 2 parallel lines are cut by transversal, then the pairs of corresponding angles are congruent. So corresponding angles, we've already talked about that they're in the same location on the same side as the transversal. And so we know that they're going to be equal to each other when it cuts across 2 parallel lines. 3.4, alternate interior angles. If 2 parallel lines are cut by transversal, then the pairs of alternate interior angles are congruent. Okay, so remember, it doesn't mean they are not necessarily congruent just because they're alternate interior, alternate exterior, corresponding, things like that. The 2 lines have to be parallel to each other for them to be congruent. Okay, so earlier when we were talking about these 4 types of angles, we were looking at lines that were not parallel. So that doesn't necessarily mean that my measures are going to be equal to each other unless it's two parallel lines. Okay, so we cannot assume congruence unless the transversal is cutting parallel lines. Same thing with consecutive interior, alternate exterior, and perpendicular transversals, okay? They're only going to be congruent in those angle relationships if it's parallel lines. All right, we had a proof going through all of that. And then example 2, using properties of parallel lines. So if I have parallel lines in a transversal and I'm given an angle measurement, I'm able to figure out the other angle measurements based on that one. Likewise, example 4 is going to be on page 145. Look at the top of 145. On the top of 145, we see that now we have expressions trying to, so by knowing my relationship between angles, I can plug in algebraic expressions to solve. Okay, so the first thing I have to understand is when I add two together, are they equal in 180? Am I looking at them based on their relationship and location? At alternate interior, alternate exterior, am I looking at corresponding angles? So the first thing I have to do is be able to identify their location and how they relate to each other. Then I'm going to use the information they have given me, whether it's an algebraic expression, a number, or a variable, to set up an equation to solve, okay? So the first thing I have to understand is their location and how it's related to another item. Then I have to understand how I can solve. So if I'm looking at this example here, if I'm looking at these two here, I know that they are going to be corresponding angles because they are on the same side of my transversal, but they're located on each of the parallel lines. So I know that I can solve for 4 based on this 125. If I know what 4 is, then I can figure out what this angle is here, the x plus 15 degrees. I can figure that out because I know that this is going to equal 180. So I have to set this plus this equals 180. So I have to understand when I'm saying this equals this or this plus this equals this, okay? So understanding what type of equation you're having to set up based on those angle relationships. Then we will move on to 3.4, proving lines are parallel. So we went in 3.3, we talked about if they're parallel, then we can prove our angles. And now in 3.4, we're saying if I have got my angles, I can prove that they're parallel. So basically we had kind of the converse here of 3.3 and 3.4. 3.4 says if my lines are parallel, then my angles are congruent. Now in 3.4, I'm saying if my angles are congruent, then my lines are parallel, okay? So not only do we use our if-then statements and our conditional statements in converse, as we're kind of seeing that here with these lessons. So basically understanding that these are the converse, and that's why on page 150, you can see that this is called, the first postulate 16 is the corresponding angles converse. If I'm proving lines are parallel because of angles, then I know it's going to be a converse postulate or theorem. So if the angles are corresponding, parallel lines. If my angles are alternate interior, parallel lines. If my angles are consecutive interior, parallel lines. If my angles are alternate exterior, then they're parallel lines, okay? So that's how 3.4 is different from 3.3. They're the same in the sense that we're dealing with angles and parallel lines. They're different in the sense that in 3.3 we said if they're parallel, then the angles are congruent. 3.4 we're saying if the angles are congruent, then they're parallel. Do y'all remember what it's called when you have an if then, if P then Q, and if Q then P are both true? What is that called?
A conclusion.
Biconditional. Okay, so it's a conditional statement that's true both ways, so it's a biconditional statement. So that's what we're seeing here. we're putting that into play, okay? So again, like I said, a lot of geometry is making these connections, thinking these things through, okay, and understanding how they relate. Alrighty, so we did learn, or we've talked about how, because I know the angle relationships, I'm going to be able to solve for unknown angles, okay? We also talked about how when I see my angles and I see my single arc, I know that they are telling me that these two are equal to each other, okay? So, and then also I have to remember back from the previous section about vertical angles, okay? We didn't cover that in section 3. So that's one of the things I want you to also remember is that everything we've covered in previous sections is fair game, okay? So they're going to be expecting you to know and to remember things that you learned in previous chapters. That's what I'm saying. It's not going to be good enough that you just cram it in and all get it done for one particular homework assignment or one particular test, because you're going to be seeing these things again. In chapter 2, we talked about vertical angles, and so now they're expecting us to remember that, okay? Proof of consecutive interior angles, applying the consecutive interior angles converse. So again here, our example that we're seeing is they said, okay, we have put these variables in the location of consecutive interior angles. Therefore, you should know, by knowing consecutive interior angles postulate, that if I add these together, they equal 180. So then I can set up an equation that x plus 4x equals 180, then you can solve. If I had one located here, if this x was just moved right here, and this one was here, then I would set, whoop, turn back around. Then I would say x is equal to 4x, okay? So if they were in corresponding locations, I would set them equal to each other, but because these are consecutive interior, adding them together equals 180. All right, moving down to example 5, identifying parallel lines. Remember, we said to be able to identify if lines are parallel, then we have to be able to tell that the corresponding angles are equal to each other. And if the corresponding angles are not equal to each other, or the vertical angles, you know, if our angle measurements do not equal each other, then I cannot say that my lines are parallel, okay? 3.5. Using properties of parallel lines. 3.5 starts out with a proof, but again, it's the kind of thing where proofs are basically taking all of these understandings of relationships of angles and things like that, putting them into a reason of how I can get from one thing to another. If we look at theorems about parallel lines, we've got theorem 3.11 and 3.12 here. If I can get my page to, there we go. If two lines are parallel to the same line, then they're parallel to each other, okay? So here, if P is parallel to R and Q is parallel to R, then I know P and Q are also parallel, is basically what that's saying. Same thing here with perpendicular. If line M is perpendicular to line P and line N is perpendicular to line P, then those are parallel lines. Okay. So that was basically it for that section for 3.5. 3.6. 3.6 kind of shook it up a little bit because we've been talking about all these postulates and theorems and talking about how to figure out if lines are parallel and perpendicular. And then lo and behold, they came and threw some algebra at us and said, hey, I want you to remember what you learned about slopes about lines. Okay, so again, like I said, it's the kind of thing where the expectation is that you recall information you have previously learned. So if you're just cramming for something and you don't learn it, then it's going to come back to haunt you later. Okay, slopes of parallel lines. We came back with our slope formula where we know that slope is rise over run. We know that slope is indicated by the letter M. And when we have a slope-intercept form equation, y equals mx plus b, that M value is telling us the slope of the line. We talked about if it's a positive number, then my slope is going to go in this direction because it is increasing in a positive direction. If my slope is a negative, it's going to start from the top and go downward because it is a negative number. We also said that if we have 2 points on a line, then we can use our slope formula. M is equal to y2 minus y1 over x2 minus a1. The most important thing to remember there is that the y's are in the top and the numerator, x's are in the denominator, okay? It does not matter your number order. It doesn't matter if I choose this one to be 0.1 or this one to be 0.2 or this one to be 1 and this one 2. What does matter is that I keep them in the same order in the problem and I have y's in the numerator, x's in the denominator. I couldn't say, hey, I'm going to take x2 minus x1 and then y1 minus y2. I can't flip-flop them like that. They have to remain consistent. So we talked a good bit about slope. We talked about how if my line is perfect on a graph and that my line and my points all are located on cross sections of my grid, how I can count my slope. It's real easy to count it just by saying, okay, rise over run. Rise means up and down, run means side to side. So I look at my up and down change versus my side to side change and I can count it without having to do math. Yay, okay? But if it does not locate perfectly on the graph, then I do have to use that formula. And so, in a lot of these examples, we had to identify parallel lines based on their slopes. And then we got into writing equations of parallel lines. And so we said, if I know that my slopes are the same, then I can write an equation of a line that has the same slope but a different b value or a different y-intercept. Okay. And so we talked about how if I have the point of that line, like here, I've got the point of the line. It is not the y-intercept. How do I know that this is not a y-intercept? How do I know that this ordered pair right here is not a y-intercept? Because x is not 0. Remember, a y-intercept, my value of x has to be 0. So if I'm trying to find the equation of a line and I have to have the y-intercept, then what I'm going to do is I'm going to use this point, I'm going to use this ordered pair here to plug into my y equals mx plus b equation. But what I'm going to do is I'm going to use that point and plug in the value of x and the value of y to solve for b. Once I have the value of b, then I can use my slope and this value that I solved for to write my new equation. Okay. And then so they just had us do parallel lines. We did not have to do perpendicular, right? I think they're saving that for us for the next section 3.7. Perpendicular lines. What did we say? How are perpendicular lines different from parallel lines? They do intersect. And what about the slopes of perpendicular lines? Negative reciprocals. So that means that I'm going to have opposite signs and it's going to flip. Okay, so if I start out with a positive slope, my negative reciprocal will be a negative slope. If I start with a negative slope, my negative reciprocal will be a positive slope. Easton?
So like, we don't have to like write it out really. Like, if we know how like just flip it and do the opposite sign, you have to like work it out. Or
Yeah, if it just says give the negative reciprocal, you just write it. I mean, if it just says write the slope. Now, if it says, if it gives you an ordered pair and you have to write the equation for a line that is perpendicular, then you do have to solve for that intercept and everything like that. So again, here, looking at slopes, determining if they're negative reciprocals. If they are, then they are perpendicular. Again, just continue to look at the slopes. Example 5 on page . Yes. 174, example 5, writing the equation of a perpendicular line. A moment ago, we said, okay, with a parallel line, I know the slope and I can solve for b to write the equation. Here, the main thing I'm going to have to do that's going to be different is if I know the slope of one line, then I have to find the negative reciprocal first. Then I have to do the same thing where I can plug in and find the value of b to write my equation, okay? If I have an ordered pair, I would just plug them in. Remember that if it says of a line going through a point and this is not 0, then this is not the y-intercept. So I'm having to solve for b to get to the y-intercept so I can write that equation, okay? So, quick rough overview. Let's go ahead and look at our chapter review. You can see on page 179, we have a summary of the different things that we have learned, what you learned, and why you learned it. That's always a good question. And then 180, starting with the chapter review. Okay, so you can see 3.1, 3.2, 3.3, 3.4, 3.5. They have given us different sections and different questions to answer, okay? So what I want to do is let's go ahead and look through these to see which ones we need to work as practice. Let's check our time. Okay. Like I said, during the break, I will be copying your extra credit that is going to apply to chapters 1 and 2, okay? We're doing chapter 3 now, so again, I'll end up doing an extra credit packet for 3 and 4. We'll do the same kind of thing. For 3.1, let's do this, okay? Everybody ready for this? This time, we're going to swap. We've been doing this, okay? We're going to swap and start doing odds. And this is what I'm going to do. I think I'm going to kind of shift a little bit. I told you guys a minute ago that we're going to kind of start shifting how we do our homework assignments. We will go into this in more depth later. I'm going to be sending you the requirements and the rules. We're going to shift doing our homework. But what I want you to do for this homework is, number 1, it needs to be on one sheet of paper, okay? So you're going to have a sheet of paper, you're going to put your name at the top, and you're going to put chapter 3 review, okay?
Do I have to write all of that, or like 3 on sheet?
I mean, if you run out of paper, one of the things I'm getting is like if it's one page and you only had 2 problems on it, I'm getting one page with 2 problems on it. And then I'm getting another page that might have 3 problems on it. And I'm getting another page. So it's the kind of thing where for like one homework assignment, sometimes some people are putting all just answers on a paper. Some people are working just a couple of problems on a piece of paper, and I'm getting 5 sheets for one assignment. So I want you to go ahead and just get a piece of paper, and actually go ahead and get it now because we're going to start working on it in class. So go ahead and get out a piece of paper, put your name on it at the top. It can be in the left corner, the right corner, the center, I don't care, just somewhere in that margin at the top. And put chapter 3 review. Alrighty. So we are going to do numbers 1 through 10 odds. Or I know that would be 1 through 9. This is page 180, 181. So it's going to be for 180 to 181, we're going to do 1 through 10 odds. We're skipping number 11 because that's a proof. We're going to pick up with number 13 through 16 odds. Still on page 181. Do you have your book open? So when I say the numbers, look at it. So page 180 to 181, we're doing 1 through 10 odds.
So
Hold on.
Right, on here or as homework?
Huh?
We're gonna write the 1 through 10 on here, or we're gonna write it at like 1 through 10 homework on a different sheet?
It's up to you. I mean, you can put it all on the same thing, so that way when you're doing your work, you can look. Now look and see what side are your holes on your paper. Okay, Easton, look at your paper. Is that gonna be the paper you're turning into me?
This one.
Okay, flip your holes over, because that's the back of your paper right there. If the holes are on the right-hand side, that's the back. No, so just flip it over, okay? So 1 through 10 odds, then we're gonna pick back up with number 13 through 16 odds. Then we're gonna turn the page to page 182. And we're gonna do 17 through 23 odds. So 17 through 23 odds. I'm gonna go over all of them in just a minute. And then I want you to look at the chapter 3 test, 183. And I want you to do let's see, number 7 is approved. We're not gonna do that. Let's go ahead and do 1 through 6 odds, or 1 through 5 odds, whatever you want to call that. So 1 through 5 odds. And then we're going to pick back up with number 9. And it will be 9 through 15 odds. 15 odds. Okay, so look at your list. I'm going to go through them again.
And this is all homework we're doing at home, correct?
We're going to start working on it a little bit in class in a minute. Okay, so look at your list. I'm going to say them again. Look at your list and see what you've written down. On page 180, 1 through 10 odds. Page 180, also 13 through 16 odds. So page 180, you have 1 through 10 odds, 13 through 16 odds. Page 181, you're going to have 17 through 20 odds. I'm sorry, 17 through 23 odds. Page 181, 17 through 23 odds. Then on, I'm sorry, I said the wrong pages for that. 182 is 17 through 23 odds. Then you have page 183, 1 through 5 odds, 9 through 15 odds.
And just making sure, we do like this part on the review paper, right?
That's the piece of paper you just wrote your name in chapter 3 review. This is where you're doing your work that you will give to me, that you'll submit. Okay?
What if we do if we can't fit it all in one piece of paper?
If you need another piece of paper, you get another piece of paper.
You can
Okay.
try use the back, is what you're saying?
You can do front, back, whatever, because if you're turning it into me, I mean, I'm not saying you have to cram all your answers on one sheet. I'm just saying that it needs to be, so if you have to have multiple sheets, then you're gonna put them together, get more multiple sheets. I'm just saying that sometimes I'm getting things where I might, for 10 problems, I might get 5 pieces of paper from people. So that's what I'm saying. It's just, I want it to be kind of consistent and put together, okay? I need a label on it so I know what pages they are. I need your name on it so I know whose they are, okay? The next part is that, let's go ahead and look on page 180 for a minute. Starting with number 1. What I want you to do is, for number 1, go ahead and write the problem. Angle 2 and angle 7 are blank angles. And then when you fill in the blank, I want you to circle your answer. Okay, now for number 3, just go ahead and look at number 3. You don't have to write this right now, My goal is to get you to kind of write the problem and then the answer. Now, there are going to be some of these that you can kind of summarize, just like number 3. Hold on just a minute. Look at number 3. It says, name a line parallel to DH. Okay? So you can either write that out, the whole thing, or you could write blank is parallel to DH, and you could use your symbols. And then you would circle your answer. Okay, so I want you to write the problem, circle the answers. All right. Now I want you to think about, am I going to be able to read this as the teacher? So neatness, I want you to kind of focus on that. The other thing is when you upload it and scan it, make sure when you take a picture of your scan before you upload it, look at it and see if you can read it. If it's blurry and you can't read it, then when I try to grade it, I can't read it either. Okay. Let's go ahead and take a break. We're going to come back and work on this a little bit. I'm going to go copy our extra credit.
Carter, this is still geometry. I'm very descriptive in my class.
Oh wait, I have a TA class.
Good luck.
Hey, you're alone.
Yeah, I am alone. I'm trying to figure out what speed lines are again.
Oh,
Lines that do not intersect and are not centrally above speed.
Your sunglasses or earphones. She's blonde, that's right. She's blonde.
I can
follow down.
If there's a, I want Google, here's a example.
Don't know when.
I didn't know you could.
I couldn't eat more bread.
That's it. I could say.
This class looks miserable.
Yeah, I wonder why.
Probably because I'm in it.
I don't know if you could.
Not good. You did it. I don't remember what I need to do.
Actually, just shows that.
What did you type in?
Just few lines and then.
No, not that.
I guess.
You didn't get the. You got the hot.
Why weren't you playing last week?
Staring at the monitor.
What did you do?
Still kinda hurt.
Oh. Or if I look at it on YouTube, you just keep staring at it.
Good.
What one of your algebra videos like goes like viral and like it's like 10 million? Lucas. One of our videos goes viral.
Okay, my Spanish teacher, Garrett is right here phone right now. He's right there. I think so. This kind of really
I just don't. I just don't.
Alec, what if one of the geometry videos goes viral? Like, she's like 10 million hits on her, like,
Yeah, not no.
Instagram. Like, hey, go on my.
What the hell? Heck, I'm doing that.
Chill out, Alex.
Don't repeat that.
yeah, I have to realize that now.
Didn't unhear that.
Your parents don't get
I can't.
Bro, Alec, chill.
When Dude, Lucas. Now we can tell the
And my
parents.
fingers down here too.
Wait, you please still play soccer?
Lucas, now we can tell
You still
the
play
parents go.
I play soccer.
We can tell the parents go look at the geometry. video.
Wow.
Wait,
Yeah, my parents are gonna watch
Are you
an hour
big or
worth of
not?
geometry. Yeah.
Lucas, we can
I
tell.
mean, I have more points than him, but
We can tell
he'll
the
be in
parents.
Tadler.
You know, Timothy, Aaron, who really told me last class when I was, and he really told me last night that he can't run 15 minutes without like putting it in.
That's.
Is he? I don't know. He doesn't.
See what I can do?
But
Wait, Timothy Aaron?
Oh,
yeah.
He went to church.
what?
You guys have
Yeah, he gets here. But he's.
Yeah, I know what I'm saying. What are 2 and 7 exactly?
Oh, yeah, definitely.
So I've been like scouring the book looking for it. Wait.
Interior.
Exterior. It's outside the lines. Bro.
Exterior.
It's exterior. The interior.
And then you have.
What does skew mean?
I bet I could box it.
Ew, no,
Table.
no. Someone has a thrown me and not.
Wait.
These Facebook requests.
Y'all.
Look at Mar.
This dude kept flirting with me. He was like married. And
Oh, I get those all the time.
I know.
One time,
He's
it was
like,
a Sharky Dye,
Heart,
Sharky Dye,
heart,
he's like,
kissy
hey,
face,
how's your day
kissy
going?
face.
One day, like, how's your day going? I'm like, okay, it's going great. I should have talked with Jesus.
This old man is like probably 60 years old, and he like kept calling me babe all the time. So weird.
Old man.
My brother on Xbox put his girl filter on his picture and he'll find you like you'll look this up. And there's like 57-year-old guy and Snapchat like
He drives a Harley.
Then one time I did it here where I went to my game, ordered the training people.
That was. Oh, that is not. That is extreme. Oh, well, we're not.
Oh. You slap Garrett and Keely, how dare you? Wow.
Jesus.
You guys in video. Got many videos.
I've heard of her. That the thing was stupid.
It was.
They were like 6-year-olds.
You
the whole time.
mean the 3 people that I didn't count?
You watched it. What was the other guy? I don't really like it. Yeah, they were just insulting each other.
I think it's funny. Like,
I don't know if y'all are trying to score this problem.
really? You don't see what he said.
All righty. So let's go ahead and while you're working on this assignment that I've just given you, I want you to kind of take some time to work on it, to start on it, okay? I'm going to come by and kind of look at things. If you have questions, or ask questions. I'm going to go ahead and pass out the bonus packet. So here's the deal about the bonus packet, okay? Number 1, this is bonus. You can do some of it, all of it, none of it. It is up to you, okay? Number 2, each one is worth 1/4 of a point. So for every 4 things you get right, you get a bonus point. That will all just be out of 0. So it will all be averaged in with your test grades, okay? So let's see how many there are here. There's 4, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. There are 50 items on here, okay? So 50 divided by 4 is going to be 12.5 points, okay? So 12.5 points of bonus. So basically what you could kind of think of it as is whatever your lowest test grade and add 12.5 points on top of it, okay? Is kind of how it would affect your average. So basically it would take a C grade up to a B grade as far as as far as your test grade. So if you made a C on a test, then that's going to bump you to a B, like it would be a B average. If you had a B on a test, it would bump you to an A. So it's the kind of thing where that's what this bonus is. Like I said, some of it, none of it, all of it. It's totally up to you. I need to see all work. If you cannot fit it on here, then you need to get a new sheet of paper and attach it to it and everything, okay? And yes, so I mean, like I said, if you want to do all your work on another piece of paper and just staple it to it, that's fine. Because some of these things, you know, like the on the bottom half of this is say if they're true or false. I mean, so there's not necessarily going to be work you have to show on something. When you have something like equations on the back, where you're doing angle equations and stuff, and you're having to write out a problem, you can either show your work over here or attach another sheet of paper. It is totally up to you, okay? What we will do is, next week we are home, so we're virtual next week, and then the next week is fall break, okay? So what we will do is I will have you go ahead and submit this. I guess we'll just submit everything on Thursday, okay? Just like we've been doing on Thursdays Wednesdays have been our submission dates, right? So Wednesday, this will be due on Wednesday. On Wednesday, I will give you your test that you will have to work on, and then you'll bring it in after fall break, okay? So I'll go ahead and pass these out. These are due Wednesday because for them to be included in this grading period, I need to have them Wednesday so they can be put in with this grading period.
Oh, one thing.
Yes.
Vertical angles equal 180, right?
Vertical angles, I want you to look back. Okay, one of the things I want to mention to you too is in your textbook, let's do a textbook walk for just a minute. Flip to the back of your book on page, I don't know what page it'll be in your book, but let me see. Okay, so if you get to, do y'all have blue lines or how do your lines? I'll use your book real quick here. Okay, so first of all, in the back of your book, if we go to page 827 in your textbook. Turn your book to page 827. You have a whole list of postulates here.
Wow.
Do you have sticky notes here or at home? This would be a great thing to sticky note. Turn the page. 828, 829, 830, 831, 832. Theorems. Okay. Now, keep turning. Now you can go through. Look on page 841. We have a whole table of symbols on 841.
Use the book.
We should have known this from the start.
842 formulas. If you turn to 842 and 843, we've got a bunch of formulas here. Tables of squares and square roots are after that. Tables of trigonometric ratios. Trigonometric. Think about SOHCAHTOA. Sine, cosine, and tangent. Remember at the very end of algebra we talked about last year?
Oh, yeah.
Yeah.
All right, then I'm going to kind of jump a few pages because then we've got exercises and appendices from chapters. Turn to page 876. 876. This starts a glossary. This is it's basically your dictionary for geometry. So like if you said, vertical angles, what is that? I can look it up. I don't have to flip back through and try to figure out what page that was covered on. I've got a glossary for that. Now, if you did want to refer back to what page you learned something on, I want you to turn to page 901. 901 is what's called an index. It's listed alphabetically. So if you were looking up vertical angles, you would look to the page that's dealing with these, page 901. Turn to, and then it tells you what page to look on. Okay? So your glossary tells you page numbers, but your index does as well. Use this. This is part of learning. When you don't know something, don't just ask somebody for the answer. Look it up. Because that whole process of looking it up, again, is going to be an experience that is instilled in your brain. And you're going to go, oh, yeah, I remember when I looked at vertical angles and I saw this and I looked at that and I turned the page and blah, blah. Oh, yeah, vertical angles are congruent. Okay? All of that starts coming back because of the experiences that you've gone through. If I stand here and tell you something, you're going to get it for that one moment in time and then it is gone. Okay? So that's what I'm trying to hopefully instill right now, is that sense of self-learning, self-motivation. You aren't going to have me to stand over you for the rest of your lives to tell you what to do. You're not going to have your parents to stand over you to tell you what to do, okay? When you get off to college, if you decide to go to college, or if you get into any kind of job, if you're not going to college, whatever you choose to do in your life, you're not always going to have somebody standing over you telling you exactly what to do every moment, every day. You have to learn how to do that. And that's kind of this process that I'm trying to switch to. Because, so knowing that, let's keep flipping for a couple of pages and go to page, I think in this book, I guess it's called SA1. Keep flipping. It's going to be after your index and after the credits. It's going to be after page 923. So basically, if you go to 923 and turn the page. Okay. These are the answers for the odds in the textbook. Okay. Now, what types of problems did I just assign? Odds. So here's the deal. When you do this chapter review, do I want you to flip to the back and write the answer down?
No.
No. I want you to do the work, and then I want you to check your work. Okay? So here's the deal. When you go check your work, so number one, you've done your work. Okay? I've given you the assignment, you do your work. Then what I want you to do is I want you to go check your work. Okay? When you check your work, I do not want you to erase anything on your original work. I want you to circle, slash, X, do something to identify which ones you missed. I want you to evaluate your work and say, what did I miss? Then you're going to get a new sheet of paper that says your name, chapter 3, corrections, just like we do with our test corrections. We're going to start doing homework corrections because I think this will help you, because I'm not liking how things are going right now. I feel like you guys may not be at the point where you really want to be, and I feel like we've been really affected based on our in and out of classroom. I feel like it's been so disjointed, the uploading the work. I've been overwhelmed trying to get the work. Therefore, your feedback on your assignments, you're not getting it till it's much later. So this is going to be a way for you to not wait for me to send something back to you. You're able to evaluate how well you did. Now, likewise, these answers are back there. So if you're totally stuck and you don't know through a problem but you've got the answer, then when you go back and try to rework it, number one, you know, if you got it right when you did the rework, okay? But if you get stuck on something and you say, I even know what the answer is, but I've gone through the problem and I've worked it out time and time again and I'm still not getting it, then go to somebody in your house and ask for help. And if they can't help, text me, email me, call me, whatever, okay? But I want to see that you have at least attempted to redo it, because I think the process of you, number one, identifying your mistakes and you correcting your mistakes before you're getting help, I think is going to help you so much more for understanding this content and getting it, okay? So that's why I've just really been struggling with how I can help each of you. Unfortunately, like right now, in the past couple of weeks, I think I've had about 6 or 7 parents reach out and say, hey, we need individual help. I can't do that. With the number of days I'm at the co-op and my outside commitments and things like that, there's not enough hours in the day for me to be able to sit one-on-one and help everybody. So I'm trying to figure out how in the whole wide world I can do the best I can do and help you also do the best that you can do, okay? And so that's where we're going to look at changing this up a little bit, is to see and help you not be so dependent on waiting for me to tell you what you don't know, but for you to figure out what you don't know first, and then come to me for help when you can't figure out what to do. Does that make sense? Okay. So you've got the answers in the back, so you can look. Now it doesn't have the processes. So like if you're trying to solve for X and you've set up an equation and it's like 2x plus 3 equals 9x minus 5. It doesn't tell you how to get to X, it just tells you what X is. And remember, I don't want to see just answers. I need to see your work. Okay, so don't give me just an answer. I don't want a page full of answers. I need a page full of work, because that's how you're going to learn. Okay, and I feel like right now, I feel like you're not getting what you need to learn this information. So this is what we're going to try to figure that out. Okay, Alec?
Just making sure. I think I understood what you just said. So instead of just giving me answers, now you want to like show our work on homework.
Yes. Yes. I want you writing the
And
problem.
we do the same thing for homework. Like we just make a redo page and then we redo our homework.
Basically, I'm shifting the same way Miss Steph is doing things. So you're comfortable with that?
Yes.
Do things like Miss Steph. Okay. And so again, this is how Miss Steph does it for Algebra 2. So if you go ahead and do it now and you're planning on taking Algebra 2 next year, you're going to have her process.
We
It's
just
going to be,
circle the problems in ink and we go back and make a redo page and then we write down the ones that were
yes.
circled.
For right now, I'm not going to be as strict on like circling and highlighting and all that stuff like
Yeah.
she is. We'll get there. Maybe after Christmas, we'll implement that. Right now, I just want you, we're just going to kind of get the process of doing the work like this. and having you check your work, you be able to identify your mistakes. Now, here's the deal about when to turn it in, okay? Because you're writing on paper and because the uploading thing has been quite a headache for a lot of people, and sometimes the system's working and sometimes it's not or whatever, on Wednesdays that we come to class, bring your work, okay? Staple it together, have it in order. Work will still be on due on Wednesdays, but you won't actually turn it in unless we are in class. Now, for those that are online only, then we'll, those people will still upload. But anyway, but for you guys that come to class, Wednesdays will be the day that everything's due. It needs to be in order, stapled together, okay? So that way you kind of turn in a packet of homework. Now, we will still go over answers. We'll still answer questions. So it's the kind of thing on Wednesdays and Thursdays, if we're in class or we're virtual, and I say, pull out your homework, what questions do you have, okay? So then, because what I've really been struggling with is grading homework, and I feel like we've covered the lesson once, and then you're doing work, and then you're getting counted off a zillion points because you're missing all this homework, and it's tanking your grade when I'm not even giving you a chance to correct it. Whereas last year, the way we always did was we did corrections and then turned in your work or whatever. So I've really been struggling with the way that the grading is going, the way that the papers have been doing and stuff like that. So I'm trying to do what's best, what is best for your learning and your grade, and then also that it's not so, you're not so dependent on me to do that stuff, okay? So right now, we're working on the Chapter 3 review. You do have me here to ask questions, but you also know the resources you have at your fingertips in your textbook. If you remember a concept but you just don't remember what page it is, go to the index, flip back. Flip to the index, look and see what page it is, go to that page, look it up. If you want to look at the glossary for a definition, look at the glossary. You've got that section back there that if you were totally stuck on an answer and you flip back there and you go, okay, I know the answer is this, how do I get there? That is going to be so much more beneficial than me showing you how to get there for you to figure out how to get there, okay? All right, so as you're working, if you have questions, let me know. I'll be happy to come help you. Please do circle your answers just so it kind of stands out. And then also when you're checking your own work, you're not having to go through and figure out where your answer is, okay? So, yes.
For this one, right here, number 5. So I know that this is at the 100 speed line. This says name speed line, GFD. Would it be like any other line that doesn't intersect it?
So remember, thinking about your definition of a skew line,
Yeah.
where are skew lines located?
Speed lines are located on the same plane. No, on
Different planes.
Okay,
So really, any line that is on a different plane is going to be skewed to
okay,
that.
so I chose EA because this is on a
Yeah.
plane.
Absolutely. Very good.
We are both kind of stuck on number 7. I mean,
Okay.
I know what we're doing. It's just a slip.
Wait, what? Angle 4 be the same thing?
And it's totally fine to work with each other and help each other, okay? Because again, that's learning. Now, for your buddy to tell you what the answer is, that's cheating. But to work together and go, hey, how do you figure this out? And so that's fine. Okay, so find the measures of the other 5 angles in the diagram above. Okay, so the measure of angle 1 is 75 degrees, okay? So look at angle 1. Now, what I want you to think about is angle 2. What do you know about the relationship between angle 1 and angle 2? Okay, so even if you don't remember the name, tell me angle 1 and angle 2 are what compared to each other? They're next to each other. Good. And if my 2 angles are next to each other, when those 2 angles are next to each other, what do they form? This. A line. What is a line equal to? 180 degrees. So if I know angle 1, and I know that when I add angle 1 and 2 together equals 180, how can I figure out angle 2? Well, yeah. Okay, so now we know 1 and 2. Okay. Now again, think about angle 1 and angle 3. They're also beside each other, so how can I figure out 3? Well, if I know 3, I can figure out 4. Then I can also look at angle 1 How does that relate to angle 5? These are gonna be corresponding. Okay, so think about what do you know about corresponding?
Measure of angle 2 is going to be the same as measure of
Why?
because
Okay. Now
and
you're
4 is
moving.
going to be the same as 1 for the same reason.
So these two are equal to each other?
2
Angle
more.
2 and angle 3?
Which one?
So angle 2 would also, or angle 3 would also be 5.
Mhm.
So these two form an 8, so then you could take
Right,
1 minus 1.5. So we know angle 4 is equal to 7. And then solve this, but will those be equal to this one?
5 is going to be the same.
Angle is parallel.
Okay, so which one is gonna be, which one's gonna correspond with angle 1?
Angle 1, 5 is going to be correspond.
Yeah, so what's the measure of angle 5?
Angle 5
Measure
is,
of angle 5 is 7.3.
this angle 1 is, oh, no, angle 1 is 75.
Angle 1,
75.
so what is angle 5?
So angle 5 would be 75.
There you go.
You're right. The measure of angle 6 is 100.
So what did you find angle 5 was?
75 degrees.
Okay, so then what is 6?
100.
Okay, so what is 7?
We don't have fun, but it's fine. So just find out, making the other 5 angles, because they already found 7.
Okay, so yeah, in the example, it tells you 1 and 7.
We do 10, right?
Huh?
Like, we're supposed to be 1 to 10 odds.
Right, but since 10's an even number, you don't do 10.
Okay, so
Okay, so, 1, 3, 5, 7, 9.
I was just making sure.
Yes.
You could.
You doing okay, Garrett? Awesome.
I think.
And I do
Okay, so what are you gonna have to figure out?
Oh, no, that.
What's the order pair for A? They're not gonna, there's gonna be some things that they don't give you, they expect you to figure it out yourself. So for 17, you're gonna have to figure out what is the order pair for A, what is the order pair for B, what is the order pair for C and D. Or if they are located on exactly, the grid, if they're at exact crossing grid locations, then you can just count it.
Okay, so
You can count your slope from A to B, figure out what your slope is, count it from C to D. So you can either use the slope formula or you can count it.
Oh, so I do white, well, then that's, yeah, it's got fine.
Yeah, it just says find the slope, and then are they parallel based on the slope? So find the slope first, you can either use the slope formula. First of all, what is slope? Rise over run, what does rise mean? Up or down, okay, so go up or down first. So if you're going from B to A, how far is up or down you go? Okay, how many?
1, 2.
Okay, and then if you went down 2, is that positive or negative?
Nick.
Okay, so your numerator is gonna be what?
Negative
Over, okay, then what direction do you go?
2.
Now wait,
Okay,
don't
so
count that from as 1.
first,
Okay, I was saying, you're
X
going,
plus
I'm
four,
sorry, you're going from
X
that one.
plus 9.
Okay, did you go left or right? So is it positive or negative? Okay, so now you've got to simplify that.
Down to 1 half.
Very good.
Miss Jennifer.
Good, so now you're gonna do the same thing
So that-
for the other
So
line.
one of 2 is going to answer, right?
Well, it says to find the slope of each line, you've gotta find the slope of this line, and then you've got to determine if they're parallel. So really, you're gonna have 3 things for that. You're gonna have the slope of line 1, the slope of line 2, and are they parallel?
Miss Jennifer, I'm stuck on number 9.
Okay,
How do you set that up?
so first of all, think about corresponding angles, okay? Okay, so in this, it says find the value of X and explain your reasoning, okay? So what do we know about these two lines? They're parallel, okay? So what other angle is gonna correspond with 4x plus 4? Look to it. Show me what other angle corresponds based on, we've learned about corresponding angles, exterior, or alternate exterior, alternate interior, vertical, all of those things. Okay, so what do I know about alternate interior angles? So that's the alternate interior.
That's just the one line, you know, right?
You know what you said?
Okay, so remember, you can either count it to figure out how you get from A to B, or you can use your slope formula. What is slope formula? Okay, so that means first you'd have to find the ordered pair for A and B. So then if you know that A, what the ordered pair is, and B ordered pair, then that's what you use for X1, X2, Y1, and Y2. And you plug it into that equation. Okay, what does congruent mean? Okay, look it up.
So we go back to the.
No.
I was trying to help him, but I had to help him without trying to do it.
Yeah, that's fine.
So,
That's fine.
if we add stuff, you said an equation, and then I'll put the equation.
Okay. So how would I set up an equation? What does that mean if they have the same measure? They're equal to each other, right? Okay. So when I say the word equal, what do you think of? What kind of symbol in algebra do we use when I say equal? So if they are congruent, which means they are equal, then that means this is equal to this. That's it, and then you just solve for x. Yeah, that's why I think y'all are making, some of this you're making way too confusing. If I know that alternate interior angles are equal to each other, then this is equal to this. So now solve for x. Oh, no. What's that going on for? What's that being done for? There you go.
I'm making it harder than it is.
So now, but remember, I don't want answers. I want this work. So that's the whole thing is on here. I want you to write 4x plus 4 equals 92. Show your work, okay? So you're gonna have a little organized area right here, and then you're gonna want to do your next one. That's fine. Yeah, if it's not, if there's not something you can say.
I'm making this harder than it is.
Okay, no.
Harder than
Okay, so you said A is, okay, so what is 2 positive or negative? Which direction on my x-axis is positive? This way or this way? Okay. So if you're doing letter A, go ahead and erase this. And write A equals, or just A, in parentheses. So you know that you've got point A. So write letter A and then start your parentheses. Okay. So from the origin, where did you go? Left 2 places, so what kind of number is that? No, if it's positive, is this direction. This is negative, so -2. Okay, and then are you going up or down or nowhere? Okay, I'm staying right there, so if I don't move, then that's gonna be 0. So now my order pair for A is -2, 0. Now what is my order pair for B? Start at the origin. Are you going left or right? How many places? Okay, is that gonna be positive or negative? Okay, so go ahead and write 2 because your x value is 2. From there, are you going up or down? Up, how many? Is that positive or negative? Good. So what's your order pair? Very good. So now, okay, so remember, yeah, so 0 minus 2 over. So you did this minus this, so then you gotta go here. Remember, you gotta go same order. You can't do this one minus this and then do this one minus this. You gotta go, you did sort of. There we go. Okay. What is 0 minus 2? What kind of 2? Okay. Over. What is -2 minus 2? Good. So now, how is that simplified? What's a negative over negative? Positive. And what's 2/4 equal to? Simplify. Okay. There you go. Okay, so you're going to do the same thing for this line. Find your ordered pairs, use your formula, and then if the slope is the same, they're parallel. If it's different, they're not.
Was it okay for me to do, I circle the ones that are on the page and I draw arrows to the page? Is that how you want it? I circled one.
You don't have to tell the page number. But I know in the chapter review that it starts on page 180 and goes and
Here it is.
okay,
Like,
that's why we skipped 11.
oh, we did.
Yeah, so that's why I did 1 through. I skipped 11 so you wouldn't have to approve. How's it going? You have any questions?
It's going pretty well.
Okay.
Well, I know this sounds bad. I couldn't find it. What does skew mean again?
Okay, so I'm gonna tell you, when I went through the book, did you hear the pages that I told you to look at?
Yes.
Okay, go to the index in the back of the book,
Yes, ma'am.
and I want you to look up the word skew and see what page it's on.
Yes, ma'am. I think I found it. Thank you.
Okay, yeah. So like I said, I want you to, you know, I know it's gonna be more work and stuff, but I think it's gonna stick with you better. So what did you find skew means?
I'm still
Okay.
I'm in the S's.
So
Few lines.
okay, so there are 2 lines. What?
So we have to like just.
I'm writing down the pages they're on, so I can remember.
It's like.
Oh, okay.
32, 134.
Okay, so
All right, thank you.
So you're finding that one
Here. You there? Sorry, I dropped out a minute.
That's fine.
So did you find skew?
Yes, ma'am. Thank you.
What did you find skew was?
I just found it was like two angles that like don't touch each other. So I thought it was GH. That's what I thought it was.
That again, I'm sorry.
All right. It's kind of hard to explain, but I kind of figured out it was like angles that like don't intersect and aren't parallel and don't really touch. So I thought it was GH.
I'll make sure that I'm like, no.
Well, did you write down your assignment?
Yes, I wrote it down.
Well, if you,
Making sure I'm 1 5. But Alex,
Sorry,
like,
Garrett.
go do it.
It's fine.
I told you.
we keep dropping out.
Yeah.
Okay. So I'm going to ask you for the 555th time. What'd you find out skew lines were?
I found out skew lines, they aren't parallel and they're not intersecting. They just kind of, they don't touch at all.
And they're not in the same plane. Okay, so you're looking for lines that are in different planes.
So I'm gonna look at it one more time just to make sure. But,
Okay.
Yeah, I think I got it.
Okay. I was going to try to.
Jennifer, I have a question.
Just a sec.
This one right here, I'm trying to figure out which theorem would like explain it. I think it might be this theorem right here. Theorem point 9, because if two lines are cut by transversal, so that consecutive into angles are supplementary. If the lines are parallel, because angle 3 and angle 4 are supplementary. Which means they're equal to 180.
Okay.
So this is angle 3 and this is angle 4.
Uh-huh.
These two angles equal one line.
Okay.
together.
So let's think about this for a minute. If angles 1 and 2 are right angles, okay, I know that 1 and 2 are right angles.
Yes.
So if 2 is a right angle, what do I know about 3?
3 is also a line.
Okay,
If
So-
four is right.
okay. So, and if 4 is a right angle, 1 is 6.
A right angle.
Okay, so,
So they're all right angles, which means phi is equal to L
okay,
or parallel to L.
okay.
So what theorem would explain that? I think it might be this one right here. Because if the two lines are perpendicular to the same line, then they're parallel.
Well, it's not asking if they're parallel though, because it says
Which lines must be parallel?
okay, yeah, so I guess if they're,
So this one would be 3.5 as well.
mhm,
Okay.
mhm. Any other questions, Garrett?
Just one more. If 17 and 19, do we do the y2 minus y1 or what? Let me see that.
You can use, first of all, you can find the ordered pairs for like A and B, and then put it into the slope formula, m equals y2 minus 1 over
Okay.
x2 minus x1. Yeah, you'll just plug them into that. And then, so you'll find the slope of the first line, find the slope of the second line. If they match, then they're parallel.
Okay.
So we've got about 2 more minutes before the bell rings. And so just be sure if you come across any questions as you're working through these, you can text me or email me or something and we can work through them, okay?
Okay.
Okay. And I hope you're feeling better and I guess I'll see you back in class after spring break, but after fall break, but then I'll see you next week online.
Yes, ma'am.
Okay. Let me know if you have questions or need help.
Thank
All right. You're welcome. We'll see you soon. Bye.
Jennifer?